Welcome to Miss D's virtual classroom. Hey guys, good to see you again. Today we're going to learn how to solve quadratic functions. Quadratic functions are often used when two things are multiplied together, hence the x squared part of the equation. For example, when you find the area of something, you are multiplying length times width. Also, when companies are looking at their revenue, they are multiplying the number of items sold by how much those items are sold for. These types of problems are called optimization problems because they are trying to figure out the maximum or the minimum value of something. They are trying to figure out the vertex of quadratic functions, specifically the y value. Another common use for quadratic functions is modeling vertical motion, like launching Angry Birds into pigs' fortresses. These are looking at when or where the birds land, the x-intercepts of the quadratic. To solve quadratic functions, we are determining the roots of the function. The roots are also called solutions, zeros, or x-intercepts. Since x-intercepts are used for graphing, graphing is one way to solve quadratic functions. Usually, graphing a quadratic function is done on the computer when a researcher is entering their data, plotting their points. This can mean plotting hundreds and hundreds of pairs of numbers before they see that the graph resembles a quadratic function because of its parabolic shape. Like it was said in the previous video,
ain't nobody got time for that.
All you need to know for solving a quadratic function by graphing is, does the graph cross the x-axis? Yes, yes, no, yes. Where does it cross the x-axis? How many times does it cross the x-axis? If it crosses the x-axis twice, then there are two real solutions. If it crosses the x-axis once, then there is only one real solution. If it does not cross the x-axis at all, then there are no real solutions. However, there may be imaginary solutions, which we will discuss later. Also, because the solutions are x-intercepts, the solutions are written in terms of x. Graphing quadratic functions by plotting points is extremely tedious and time-consuming. So I'm going to save you the headache and show you how to solve quadratic functions algebraically. You're welcome. There are 5 methods for solving quadratic functions: graphing, factoring, using square roots, completing the square, and the quadratic formula. These are the 4 methods for solving algebraically. If you take into account the 3 methods for factoring, the greatest common factor method, the X-Men method, and the evolved X-Men method, then there are actually 6 total ways to solve quadratic functions algebraically. 6 awesome tools in your tool belt. Like working on a car or fixing the house, you sometimes need to use or try multiple tools in order to get the job done right. So you will most likely use more than one method to solve quadratic functions. For now, we will not be discussing the quadratic formula. It will be its own special video. Remember that the solutions of the quadratic function are also called zeros? Well, that's because they lie on the x-axis, which is the line y equals 0. For any point on this line, the x values can change, but the y values will always be 0. This truth allows us to solve quadratic functions by setting the equation equal to 0. Okay, let's start with the equation y equals negative x squared minus 2x plus 15. First, I need to set my equation equal to 0. Since there is a negative sign in front of the leading coefficient, I'm going to use the Gcf method to factor out a negative 1 from all the terms. I notice that the expression within the parentheses is of the form x squared plus bx plus c. So I'm going to use the X-Men method. What two numbers multiply to equal negative 15 and add to equal 2? Positive 5 and negative 3. Write this equation in its factored form, which is x plus 5 times x minus 3 equal to 0. Now you're going to use the zero product property to solve the equation. X plus 5 equals 0 and x minus 3 is equal to 0. Our solutions are x is equal to negative 5 and x is equal to 3, which are two real solutions. To check, I'm going to plug negative 5 into the equation and see if I get an answer of 0. I get negative 25 plus 10 plus 15, which does equal 0. If I plug 3 into the equation, I get negative 9 minus 6 plus 15, which also equals 0. So my two solutions do in fact work for this quadratic function. To solve this quadratic function, I use the Gcf method and the Xmen method and the zero product property. Okay, let's try another one. Y equals 6x squared minus 54. First, set the equation equal to 0. Next, there is a common factor of 6 between the two coefficients, so I'm going to use the Gcf method and factor out 6. Dividing both sides by 6, I am left with x squared minus 9 equals 0. Now I can use the square root method because this equation is of the form x squared plus c. To use the square root method, I'm going to add 9 to both sides. I get x squared is equal to 9. Then I'm going to take the square root of both sides. Remember, when you take the square root of a number, you should have two answers, a positive answer and a negative answer, which is why I have x is equal to plus or minus 3. So my solutions for this equation is actually x is equal to negative 3 and x is equal to positive 3. If I plug negative 3 into the equation, I get negative 3 squared, which is equal to 9, times 6, which is equal to 54, minus 54, which becomes 0. If I plug positive 3 into the equation, I get positive 3 squared, which is equal to 9, times 6, which is equal to 54, minus 54, which is also equal to 0. So these solutions do in fact make the equation equal to 0. I have the right solutions. Again, to solve this problem, I used the Gcf method and the square root method. This was a simple example, but it works the same for a complicated problem like 6 times x minus 3 squared minus 54. First, I add 54 to both sides. Then I divide both sides by 6. Now I'm going to take the square root of both sides, and I get x minus 3 is equal to plus or minus 3. To solve for x, I need to add 3 to both sides. So I get x is equal to 3 plus or minus 3. This is the same as saying 3 plus 3 and 3 minus 3. So my solutions are x is equal to 0 and 6. If I plug 0 into the equation, I get 0 minus 3, which is equal to negative 3, squared, which is equal to 9, times 6, which is equal to 54, minus 54, which is equal to 0. If I plug 6 into the equation, I get 6 minus 3, which is equal to positive 3, squared, which is equal to 9, times 6, which is equal to 54, minus 54, which is also equal to 0. So my solutions are correct. That is how you use the Gcf method and the square root method. Let's try solving a more complex equation. 2x squared plus 8x plus 14 is equal to negative 12. Now this is not the traditional y equals something equation, but what this equation is asking is, what are the solutions if y is equal to negative 12? We would still have to set the equation equal to 0 in order to solve it. So we have to add 12 to both sides, and we get 2x squared plus 8x plus 26 is equal to 0. All of the coefficients have a GCF of 2, so we can use the GCF method and factor out 2, which gives us 2 times x squared plus 4x plus 13. Now divide both sides by 2. We get x squared plus 4x plus 13 is equal to 0. Since this equation is of the form x squared plus bx plus 13, we can use the Xmen method. What two numbers multiply to equal 13 and add to equal 4? There are no two numbers that do that, so the Xmen method does not work, which means we're going to have to solve this equation using completing the square. To complete the square, we have to have ax squared plus bx on one side and anything else on the other side. So we have to subtract 13 on both sides. We now have to complete the square for x squared plus 4x by adding a number such that it becomes a perfect square trinomial and can be written in factored form as x plus something squared. Remember, if we add a number on one side, we have to add the same number on the other side to keep the equation balanced. Since 4 is our b coefficient, we can put that at the bottom of our Xmen symbol. To make a perfect square trinomial, we have to find a number added to itself to equal b, which is 4. 2 plus 2 equals 4. Therefore, our constant term is equal to 4, since 2 times 2 is equal to 4. We put that back into our equation, and we get x squared plus 4x plus 4 is equal to negative 13 plus 4, which is x squared plus 4x plus 4 is equal to negative 9. Although we have completed the square, we're not done yet. We still have to factor it and solve it. So factoring x squared plus 4x plus 4 to be x plus something squared, our something is the factors 2. So we have x plus 2 squared. Rewriting the equation, we get x plus 2 squared is equal to negative 9. Now we can use the square root method. Taking the square root of both sides, we get x plus 2 is equal to plus or minus 9. We can't technically take the square root of negative 9, so this quadratic function will have no real solutions. However, we can solve for imaginary solutions. Remember that the imaginary number I is equal to the square root of negative 1. If not, the imaginary number of I is equal to the square root of negative 1. Since our equation is x plus 2 is equal to plus or minus the square root of negative 9, we can rewrite the square root of negative 9 as the square root of 9 times the square root of negative 1. To simplify, we'll get 3 times I. So our equation is x plus 2 is equal to plus or minus 3 times I. To solve for x, we subtract 2 from both sides and we get x is equal to negative 2 plus or minus 3i. And our solutions are then x is equal to negative 2 plus 3i and x is equal to negative 2 minus 3i. These are our imaginary solutions. It is fine to leave your solutions as this. Here's our last example. 6x squared minus 3x is equal to 9. First, there is a bx term in our way, so we can't use the square root method. We must proceed by setting the equation equal to 0 to solve it. We get 6x squared minus 3x minus 9. There is a GCF of 3 for all terms, so we can use the Gcf method and factor out 3. We get 3 times 2x squared minus x minus 3, which is equal to 0. Divide both sides by 3 and we get 2x squared minus x minus 3. Since this equation is of the form ax squared plus bx plus c, we can use the evolved Xmen method. First, we have to multiply a and c for our top number, which is equal to negative 6, and our bottom number will be the b coefficient, which is negative 1. The two numbers that multiply to equal negative 6 and add to equal negative 1 are negative 3 and positive 2. So our factored form quadratic is 2x minus 3 times 2x plus 2. Remember, if we multiply by a, it has to be in our factored form. However, we also need to divide by a to undo that multiplication. So the actual factored form is 2x minus 3 times x plus 1. Using the zero product property, we get 2x minus 3 is equal to 0 and x plus 1 is equal to 0. So our solutions for this quadratic are 3 halves and negative 1. Woo! We're all done! I'm so proud of you for watching this video. I hope it clears up any of your confusion. If not, watch the video again or watch parts of it. For your homework tonight, you have practice problems on page 485, numbers 5 through 12. You will be doing it on a worksheet. Grab the worksheet from me after you're done watching the video. I want you to show your work and list which methods you used. I want you to choose one problem and describe how you solved it, specifically stating concepts, methods, and properties you used. Lastly, you will be taking the quiz retake tomorrow, Friday. It is a minimum day, so you have 29 minutes. Make sure you know how to graph and solve quadratic functions. That's it for today. Good luck, and may math be with you.